Okay, so I'll blab a little while, and then I'll let you ask questions. So today is our question and answer day. You can ask me anything, and the coverage of your questions should just be one of these previous exams. Okay, I have here. So at this stage of the game, don't look at the book. Don't look at your homework. It's not necessary. There's too much to study that. Just study the previous exams. Okay. For the final exam, I'm pretty much set on 15 questions, 3 from each test. How's that? Okay, so 3 from the first test, 3 from the second test, 3 from the third test, 3 from the fourth test, 3 from the fifth test. I'm not promising they're the exact same questions, although they could be in some cases, but maybe just slight modifications of them. So, I mean, it's not that hard, I think, to go back and review every test, or just do the test, and that's what you want to do. You can have all the previous cheat sheets, so 5 cheat sheets, and if you want to add to it, put something extra on it, you're allowed to do that, front and back. And so any questions you have has to be tonight. So Thursday, once class starts at our starting time of what, 7:10, so 7:09-ish, something like that, I will send through Canvas announcements the exam, and you can get started right away with the final exam. No questions and answers on Thursday, so it all has to be today. And so you have until 9:25 p.m., so what, 2 hours and 15 minutes to do the final exam. So aiming for 15 questions, 3 from each exam. Okay, and that's the best way to study. Then I'll close the class as normal. You have 5 minutes to turn in the exam, so 9:30. Of course, there's no homework to turn in this time, so then that would pretty much be it. And then we're finished with the course. And then that's it. Yay. And we're all done. Okay. And let's see. I think that's all I have to say about that. So it's just like any other test, except it's, of course, worth more and there's more questions, but you don't have to turn in any homework. So once you join, I mean, you're used to hearing me lecture, but there is no lecture for the final exam. So once you go to Canvas announcements and get the test, just start like any other test. Have your camera on and mute yourselves and just get going with the final exam. Okay. All right. So I think that's about it. I'll go ahead and start taking questions, or if you have any questions about anything, that's fine. How I got you. Let's see. Final exam is from the previous exams, yes. Okay. And let's see. Not sure how to do this now. How to use calculus to make a triangle. I'm not sure what you mean by that. Want to get more specific for that, or do you have a particular question? You can. All right, exam 1, question 2. Okay. Okay. Test 1, number 2. Maybe I'll notate like this: the test number and then the problem number. Use calculus to find the area of the triangle. Okay. 0, 0, 2, 6, -1, 2. Okay. So this determines a triangle. Find the area of that. Okay. Quickly here, I know a lot of you are putting other stuff in here. So, and if I miss a question, then get back to me. How many points is the final exam? The final exam is 300 points. Okay, so it's like you're taking 3 100-point tests. Okay, so that knocks that off. All right, so let's see what we can do with this one. Okay, 2, 6, -1, 2. Let's see, let me move the chat over so it's not taking up my space here. Okay, so this is y equals 3x, right? Rise over the run. Okay, -1, 2. So the slope is -2. So y equals -2x. Okay, this one's a little bit harder. Okay, so slope is 6 minus 2. divided by 2 minus a negative 1, which is 4/3. So y minus y1, how about y minus 6 equals m times x minus x1, x minus 2. Y equals 4/3 x minus 8/3 plus 6 plus 6. So y equals 4/3 x plus 10/3. Okay, so the area is this region plus this region. This one upper minus lower. So integral from -1 to 0. Upper is 4/3 x plus 10/3 minus a negative 2x dx plus then the integral from 0 to 2. Same upper minus the lower. So 4/3 x plus 10/3 minus 3x dx. Okay, let's see. This is 4/3 x plus 2x. So 4/3 plus 6/3, 10/3 x plus 10/3 dx. There's a double negative here, right? So you can make this into a positive. So it's 4/3 x plus 6/3 x. Okay. You go from 0 to 2. 4/3 x minus 9/3 x is negative 5/3 x plus 10/3 dx. Okay, and I think the best way to do this is factor out the 10/3, factor out a 5/3. Okay, so 10/3 going to go from 0, from -1 to 0 of x plus 1 dx plus, I'll take out a 5/3 and go from 0 to 2 of, let's see, negative x plus 2. Double check with distribute, negative 5/3 x. Yeah. Okay, so go back up. X squared over 2 plus x, negative x squared over 2 plus 2x. 10/3 x squared over 2 plus x, 0, plus 5/3 negative x squared over 2 plus 2x. Negative x squared over 2 plus 2x, 0 to 2. Okay, plug in 0, you get 0. Plug in -1, 1/2 minus 1. Plug in 0, you get 0. Plug in 2, let's see, -2 plus 4. So I get 10/3 times 1/2 plus 5/3 times 2, which is 5/3 plus 10/3, which is 15/3, or 5. Looks like the answer is 5. Okay. All right, so that's that one. Exam 1, question 2. I just did that. Okay, exam 1, question 4. We're using dishwasher method, find the volume of the solid general. Okay, so x equals y squared and x equals 1. spin it about x equals 2. Okay, so x equals y squared, x equals 1. And we're spinning it about x equals 2. And let's see, this is 1, 1, 1, negative 1. So we're spinning it like so. So if it asks for the disk or washer method, I'm spinning it like so. So this is a tiny little delta y. Okay. So I've got a little radius and a bigger radius. This little radius is 1. This distance is 2. This distance is x. So the bigger radius is 2 minus x, which in this particular case is 2 minus y squared. Okay, now if I slice this way with delta x and I spin it around this way, I would not see a disk, I would see a shell. So that tells me that I'm doing integral with delta y. Okay, if I spin this way, I see a disk. Actually, there's a small disk and there's a bigger disk. I'm taking the bigger one, not the smaller one. And I'll use symmetry. If I integrate from negative 1 to 1, for this picture, I'll just integrate from 0 to 1 and multiply by 2. So the volume is twice integral from 0 to 1 of pi times the bigger radius squared. So the bigger radius is 2 minus y squared, minus pi times the smaller radius squared. Smaller radius is just 1 squared dy. Okay, take out the pi. Okay, so square this, 4 minus 4y squared plus y to the 4th minus 1 squared is 1 dy. So pi r squared, big R, pi little r squared. Pi also. Pi. Okay, 4 minus 1 is 3. Now, 1. 3 minus 4y squared plus y to the 4th dy. Okay. Now it shouldn't be too bad. So 3y minus 4y cubed over 3 plus y to the 5th over 5, 0 to 1. Plug in 0, you get 0. Plug in 1. 3 minus 4/3 plus 1/5 minus 0 minus 0 plus 0. The rest is arithmetic, so to save time, we can go straight to the answer. I'll keep it in my notes. 6 pi over 15. Okay. 3 minus 4/3 plus 1/5 times 2 pi comes out to be that. That's just arithmetic. Okay. All right, let me see. Exam 1, question 10. Okay. It's very easy for me to miss stuff now. So if I miss something, then just ask me again. And I'll probably have to go out of order now. Okay, problem 4 from the last test. That's 5 right through. Test 5, number 4. Summation 1 over n squared e cubed plus 1 3. Okay, so when n gets big, you ignore the 1. So the other way around. Can't read. That's a 2. That's a 3, right? Okay. So often you can tell what to compare by saying what happens when n gets big. You forget about the 1, right? So it's 1 over n to the 2/3. Summation 1 over 3 root of n squared. 1 over n to the 2/3. So limit n approaching infinity of the ratio. 1 over cube root of n squared plus 1 over 1 over cube root of n squared. Multiply top and bottom by cube root of n squared. And the reason why you do that is now you can just totally forget that, right? And now these are both cube roots, so I'm allowed to put them under 1 cube root. Cube root of the whole thing, n squared over n squared plus 1. Divide top and bottom by n squared, like that. And then n approaches infinity. Cube root of 1 over 1 plus 1 over n squared. And now when n gets big, that approaches 0, so the limit is 1. Which is a number that's not 0 and not infinity. So whatever happens to one happens to the other. What happens to this one? What happens to this one? Okay, so now summation 1 over cube root of n squared, which is the same as summation 1 over n to the 2/3 diverges. Reason, it's a p series. Where p is equal to 2/3, it's less than 1. And therefore, the original series also diverges by limit comparison test. Okay. Exam 1, question 10. Okay. Unfortunately, when they're out of order, it takes me time to switch back and forth. Exam 1, question 10. Temperature function, T of T. Capital T is temperature, little t is time. 50 plus 6 sine pi t over 12. It's pi over 12t. When the average temperature from 9 a.m. to 9 p.m., 9 a.m. is the start, so 9 to 9 is 0 to 12. Okay. So average temperature is length of the interval, 1 over being divided, 1 over 12. Integral from 0 to 12, 50 plus 6 sine pi over 12t equals 112. 50t, integral of 6 sine is negative 6 cosine pi over 12t, then by the chain rule times 12 over pi, 0 to 12. Okay, so plug in. Okay, 50 times 12 minus 6 times 12 over pi times cosine of pi, which is negative 1. And that's that. Then when I plug in 0, I have 0 minus 6 times 12 over pi cosine of 0, which is 1. I have this weird expression. I'm very fortunate I can cancel all the 12s. Makes it a bit easier. So it comes out to be 50 minus a minus is plus, plus 6 over pi, plus another 6 over pi. 50 plus 12 over pi, approximately 54 degrees. Okay, let's see. Exam 2, 3, 5, and 6. Is it possible to get an update on attendance? Send me an email. Test 2, 3. Integral of sine cubed cosine squared x dx. Okay, this has an odd and an even, so that's the easier case scenario. Change the odd one into a separate sign, like that. And now you want all of this to say only cosine. I can do that since sine squared is 1 minus cosine squared, so I'll write it like this. 1 minus cosine squared x, cosine squared x. Okay, sine squared x, there it is. Cosine squared x, there it is. Sine x dx. So this will all become a u. So u equals cosine x, du is negative sine x dx. I need a negative 1 inside and outside. So now my integral is negative 1 minus u squared times u squared times negative 1 sine dx, which is du. So that's the integral u squared minus u to the fourth. I'll distribute the negative. U to the fourth minus u squared du. So u to the fifth over 5 minus u cubed over 3 plus c. Change u back to what it was. 1/5 cosine to the fifth x minus 1/3 cosine cubed x plus c. Paper's curling on me again. Five integral of x cubed 4 minus x squared dx. Okay, so 4 minus x squared, that's a squared minus x squared, where I use a sine theta, so that x be 2 sine theta, right? X is 2 sine theta, dx is 2 cosine theta d theta. Okay, so x cubed is 8 sine cubed theta. Radical 4 minus x squared is 4 sine squared theta, which factors into 4 times 1 minus sine squared theta. And then dx, 2 cosine theta theta. So now I have what? 8 sine cubed theta, radical 4 cosine squared theta. 1 minus sine squared is cosine squared. 2 cosine theta d theta. And all of this is 2 cosine theta. So then we have 8 times 2 times 2, 32. Sine cubed theta cosine squared theta d theta. Sine cubed cosine squared. Unfortunately, we just did that. Right, so I'll just peek at that answer. 42 times 1/5 cosine to the fifth theta minus 1/3 cosine cubed theta plus c. Then you have to triangulate. Okay, x is 2 sine theta. Here, x equals 2 sine theta. Sine of theta is x over 2. Mess up a triangle. Sine is opposite over hypotenuse. Do some Pythagorean theorem or just peek back at the original. You're probably right. Radical 4 minus x squared. Double check. If you square this, you get 4 minus x squared. Square that, you get x squared. So if you add them up, you get 4, which is 2 squared. Okay. So if I can sneak this in, 32 1/5 cosine theta to the 5th. And I'm running out of paper here. So minus 1/3 cosine cubed plus c. Sorry, I'm writing down vertically. And what is cosine? Cosine is adjacent over hypotenuse. So radical 4 minus x squared over 2. Radical 4 minus x squared over 2. Okay, I'll leave it like that. Or this one. Okay, number 6. Back to the time here. 6, integral of dx over radical x squared plus 25. So that looks like this one. So x is equal to a tan theta. So in this case, it's 5, right? X is 5 tangent theta. Dx is 5 secant squared theta d theta. So integral of dx is this stuff. 5 secant squared theta d theta over radical x squared, so 25 tangent squared, right? 25 tangent squared theta plus 25. Factor out of 25, you have 25 tangent squared theta plus 1. And that's the whole idea, because tangent squared plus 1 is secant squared. So 5 secant squared theta d theta over square root of 25 secant squared theta. And that becomes 5 secant theta, the next step. 5 secant squared theta d theta over 5 secant theta. 5's cancel out. A secant cancels out. So I'm just integrating secant. Okay, and that's ln absolute value secant theta plus tangent theta. Okay, put that on your formula sheet if you haven't already done so. Okay, triangulation time. X is 5 tan theta. X is 5 tan theta, which means tan theta is x over 5. Tangent is opposite over adjacent. Hypotenuse, just peek at here. Radical x squared plus 25. Double check. A squared plus b squared equals c squared. X squared plus 25 is equal to this squared. Okay, so ln secant is a reciprocal of the cosine. So it's hypotenuse over adjacent. And then tangent, opposite over adjacent, x over 5 plus c. Okay, and I said I would accept that, but the absolute best is to write it like this. Okay. You could get this common denominator and use property of logs. You'd have ln of this minus ln 5 plus c. Minus ln 5 plus c is just plus c. And this quantity can never be negative or 0. So put parentheses there. Okay, so that's that. Okay. All right. Then 1 question 9. be surprised if I lost one of these tests in the shuffle here. Test 1, number 9. Find the average value f of x e to the negative x squared, from 0 to 3. So the likelihood was 1/3. So f average is 1/3. Integral from 0 to 3 of x e to the negative x squared dx. U equals negative x squared. Du is negative 2x dx. Negative 2, negative 1/2. X equals 0, u equals 0. X equals 3, u equals negative 9. Change the limits of integration. So the integral is negative 1/6. Integral from 0 to negative 9. E to the negative x squared is now e to the u. Negative 2x dx is du. Let me switch these around and make that a positive. 1/6 integral from negative 9 to 0, e to the u. 1/6 u from negative 9 to 0. 1/6. Plug in 0, you get 1. Plug in negative 9, you get e to the negative 9. Exam 4, 8, 9, and 10. Whoops, that one's supposed to be red. Give the vertex, focus, and director of the parabola and sketch. X minus 2 squared equals negative 12 times y plus 3. See the question, here it is. Yeah, okay. If I went too fast, it's being recorded. So check it later. X minus 2 squared equals negative 4 times 3. Y plus 3. That means p is 3. Squared in x, not in y. And negative means opens down. Vertex, read it right off. It's 2, negative 3. And 2, negative 3 is the vertex. P is 3. I know it opens down. So I go down 1, 2, 3 for the focus, which is 2, negative 6. I go up 3 for the directrix, so it's just the x-axis. Y equals 0 is the directrix. And I'll go like that. So let's see, vertex. Vertex, got it. Focus, got it. Directrix, got it. Sketch, got it. Okay. All there. Number 9, find the vertices and foci of the ellipse and sketch. Okay. X squared plus 4y squared equals 64. Divide by 64. X squared over 4 plus y squared over 16 equals 1. A is 4, B is 2. A squared equals B squared plus C squared for the ellipse. A squared is 16. B squared is 4. C squared equals 12. C is radical 12, which is 2 radical 3. It's about 3.6, I believe it is. P. .5. Okay. Center at the origin, up and down is 4. 1, 2, 3, 4. 1, 2, 3, 4. Left and right is 2. 1, 2, 1, 2. So vertex 1 is 0, 4. Vertex 2 is 0, negative 4. Negative 2, 0, 2, 0. They don't have any special names. Focus, I go up and down 3.5. So focus 1, 0, comma, 2, radical 3. Focus 2, 0, comma, negative 2, radical 3. Okay. 10. Foci 0 plus or minus 13. Vertices 0 plus or minus 5. Okay. Foci are 0 plus or minus 13. Vertices are 0 plus or minus 5. That means C is 13 and A is 5. A squared plus B squared equals C squared for the hyperbola. 25 plus B squared is 169. Subtract 25, B squared is 144. B is 12. Okay, the foci are here and here. Vertices here and here. That means it's going like so, which means y comes first. It's centered at the origin. So y squared over something minus x squared over something equals 1. The somethings are a squared, which is 25, and b squared, which is 144. Okay, that's it for that one. Okay. I don't remember where I left off. Okay. I wonder if you guys are going to have me do all the problems. Is that your strategy? You can do everything? We're out of order now. Then 2, number 4. 2, number 4. Cotangent squared x. Okay, cotangent is cosecant squared x minus 1. There's an identity from trig, 1 plus cotangent squared x equals cosecant squared x. Put that in cheat sheet if you want. That means cotangent squared is cosecant squared minus 1. Okay, so there it is. Integral of cosecant squared is negative cotangent x minus x plus c. Okay. Okay. Exam 2, question 1. EVX sine x dx. Okay, integrate by parts. U equals EVX, dv equals sine x dx. Time again. Lose track of time. D equals EVX dx. If it gets to be 8:15, 8:20, and I'm not stopping, somebody holler and scream at me, we take a break. Okay. I just get going, Okay, so I is uv negative e to the x cosine x minus the integral of v du negative cosine x e to the x dx. There's a double negative. So negative e to the x cosine x plus integral of e to the x cosine x dx. I'll call that I1. So I is negative e to the x cosine x plus I1. Now I work on I1. I1, integrate by parts. U is e to the x. dv is cosine x dx. du is e to the x dx. dv is sine x. So I1 is uv e to the x sine x minus the integral of v du e to the x sine x dx, and that happens to be the same as the original integral I. Way back over here. In other words, I1 is e to the x sine x minus I. pick that up and plug it back into here. So I is negative e to the x cosine x plus I1, here's I1, e to the x sine x minus I. So add I to both sides, 2I equals, and what do I factor out e to the x? And how about I write it as sine x minus cosine x? And then just divide by 2 or multiply by half. So I is 1/2 e to the x sine x minus cosine x plus c. That. Question 2, same test. We go ln cube root of x dx. Ln x to the 1/3, and then take the 1/3 out. Okay. So you can do that by parts, or if you have it memorized or you've written it down, go by 2 at x ln x minus x plus c. So the integral of ln x is this. You can caught that. So there it is. Okay, let's see. How many quizzes do we have? We had 12. Okay, exam 4, number 4. Whoops, it would have to be red. That leaks out. 4. Find dy dx and d squared y over dx squared. X is 3 cosine t, y is 4 sine t. X is 3 cosine t, y is 4 sine t. dy dx is dy dt divided by dx dt. Put that in your cheat sheet if you need it. So 4 cosine t over negative 3 sine t, which is negative 4/3 cotangent t. That's dy dx. D squared y over dx squared is the derivative of dy dx with respect to t over dx dt. Put that on your cheat sheet if you need it. Well, dx dt, we already did that. Let's copy that. Negative 3 sine t. Derivative of dy dx with respect to t. The derivative of negative 4/3 cotangent t is positive 4/3. Derivative of cotangent cosecant squared t. And this 3 can slide down. Sine on the bottom means cosecant on top. So negative 4/9 cosecant cubed t. That's one number 4. That's one number 9. I think I did that. That's 4 number 2. Okay, eliminate the parameter and find a Cartesian equation. That's an arrow increasing t. Okay. X is secant t, y is cosine t. T is between 0 and pi over 2. Okay, secant is 1 over the cosine, and I notice that's the same as y. So x is 1 over y, or y equals 1 over x. The entire graph of y equals 1 over x looks like this. Let's see what we have here. Okay, if I plug in 0, cosine of 0 is 1, reciprocal of 1 is 1, and it's an open circle, because I'm not counting that. And we get close to pi over 2. So if I'm at that's 90 degrees, so 89 degrees. Okay, cosine of 89 degrees is very close to 0. So the y coordinate is very close to 0, so we're going this way. We don't really have that. We don't really have that. We just have that. Okay, I kind of lost track of where I was. That's number 2. Test 2, number 8. Test 2, number 8. Negative x plus 8. X squared minus 11x plus 30 dx. Okay. Negative x plus 8 over x minus 5, x minus 6 dx. Okay, so partial fractions, negative x plus 8 over x minus 5, x minus 6 equals a over x minus 5 plus b over x minus 6. So in common denominator, multiply this one by x minus 6 over x minus 6, x minus 6. Multiply this one by x minus 5, x minus 5, x minus 5, x minus 6. So ax minus 6a plus bx minus 5b over x minus 5, x minus 6. Okay, factor out x. So a plus bx plus negative 6a minus 5b over x minus 5, x minus 6. Look back at the original, it's negative 1x. Change color here. Negative 1x plus 8. Negative 1x plus 8 over x minus 5, x minus 6 equals this. So that means that has to be negative 1. That has to be 8. So a plus b equals negative 1. Negative 6a minus 5b equals 8. So you multiply this equation by 6. 6a plus 6b equals negative 6. Add them up. B equals 2. Plug back in here. That means a is negative 3. Plug in 2 right here. A plus 2 is negative 1. Subtract 2. Okay. So the original integral has negative 3 on top. Here, this is a negative 3. And this is a 2. Now we've established that. Okay, so I is the integral of negative 3 over x minus 5 plus 2 over x minus 6 dx. Okay, that's pretty much it. Let me do the positive first. So 2 ln absolute x minus 6 minus 3 ln absolute x minus 5 plus c. Okay, and it's just about 8 o'clock, a little bit past 8 o'clock. And let's see, which is the one that I just did. Okay, exam 4. Okay, I'm not sure where I am. Well, let's see how we're doing here. Go back to exam 2, question 1. I don't know where that is anymore, unfortunately. So that might be a while. Yeah, I can't find it right now. It's going to be too hard to do that. Let's take a break right now. I think, let me stop the share. You can keep putting stuff in the chat if you wish. But 8:02. Okay, let's start up again at 8:15 then. Okay, you can put more stuff in the chat if you wish. Okay, so, but otherwise we'll take a break now. Okay, folks, it's 15 after. Let's try to finish up and go as much as we can. Let's see. I'll have to turn off the
对
chat
啊，可是
temporarily.
他就是说话呢，说我不听。
Go back to sharing the screen.
他走了吗？哦，It's okay. No, it's fine.
Okay, somebody is talking,
Okay,
so can you
let's-
mute yourselves? Everybody please mute.
Let's just review.
Somebody asked about the end of test 2, question 1, so
Yeah.
here it is again.
It's okay.
Hold just for a few seconds. That takes care of one of the questions.
我可以自己
What's
做。
going on? Let me see if I can get the chat back up.
谢谢妈妈。I know.
I can still hear somebody. Can somebody please mute? Everybody please mute yourselves,
It's fine.
please.
你不用给我做，用买了就可以好。I know you love me just because you buy it
Hello?
for me. 我可以自己做。
Can you mute, please? Okay, that's not working. Well, unfortunately, I got to look around and see who is not muted. Should I take away points? Let's see. Yes, this is a waste of time. Okay, I think everybody's muted. One of the great things about being what do you call it? The host. Yeah, I don't even know it's called the host, but you get to mute other people. So I think I'm okay now. All right. Well, that was another extra break. So let's get back to where we were, which means I got to press this button and press this button and press this button. And there we go. Okay. And I got to bring the chat back up. So let me see if I can do that. And where did I leave off? Test 2, question 8. Okay, test 4, question 6. I think we're back up where we were, I hope. Test 4, question 6. Let me move the chat box over so it doesn't get in my way. Okay, one loop of r equals 3 sine of 2 theta. One loop. R equals 3 sine of 2 theta. Okay, so a little mini table here. Okay, we plug in 0, I get 0. If I plug in pi over 4, I'm taking the sine of pi over 2, which is 1. 1 times 3 is 3. If I plug in pi over 2, I'm taking the sine of pi, which is 0. Okay, so there's one loop. So a very crude graph is it starts at 0, 45 degrees it goes out to 3, and then at 90 degrees it comes back in. Okay. So that's one loop. Okay, so the area is the integral from 0 to pi over 2. Formula is 1/2 r squared d theta. 1/2 r squared, 3 sine 2 theta squared d theta. This is the formula. Put it on your cheat sheet if you wish. Okay, so this is going to be 9 times 1/2, so 9 halves. Is that right? 9 halves integral from 0 to pi over 2 of sine squared of 2 theta. D theta. 9 over 2. So use the double angle formula for the sine squared. 1 minus cosine, double the angle. So 4 theta over 2 d theta. 2 joins the 9 over 2, so 9 over 4. 0 to pi over 2. Okay, so now integrate. Integral of 1 d theta is theta. Integral of negative cosine 4 theta is negative sine 4 theta. And then by the chain rule, if I differentiate, I would multiply by 4. So since I'm integrating, I multiply by 1/4. 0 to pi over 2. Okay. And this is one of those where you plug in pi over 2, you get pi over 2. everything else comes out to be 0. That happens a lot. So pi over 2 minus sine of 4 pi over 2, that's a sine of 2 pi, which is 0. And if you plug in 0, you get 0 minus 0. Okay, so 9 pi over 8. All right. So that's that one. Test 3, number 1. Use the arc length formula to find the length of the curve from 0 to 5. Check your answer by noting that it's part of a circle. Okay. Test 3, number 1. Y equals radical 25 minus x squared between 0 and 5. A little bit of algebra gives us x squared plus y squared equals 25, which is circle center of the origin of radius 5. But if you just have it written like this, you only have the top part, because y is positive. Okay, so x squared plus y squared equals 25 looks like that. Y equals is that, and you're going from 0 to 5, so you only have that. So it's 1/4 of a circle. So the arc length should be 1/4 of the circumference, which is 2 pi r, which is 1/4 of 2 times pi times 5, which is 5 pi over 2. Okay, so I've done the second part first. Okay, and now by the arc length formula. Arc length formula is this. You can put it on your cheat sheet. So here's the function, 25 minus x squared to the half. So dy dx is 1/2 25 minus x squared to the negative 1/2 times negative 2x. 2 cancels. So I have negative x over radical 25 minus x squared. By formula, I'm supposed to square that. When you square it, that gets rid of the negative, and that gets rid of the square root, so that's nice. X squared over 25 minus x squared. Then by formula, I'm supposed to add 1. 1 plus dy dx squared. 25 minus x squared over 25 minus x squared. There's 1 plus x squared over 25 minus x squared. X squared cancels out. So 25 over 25 minus x squared. That goes underneath the radical here. So the arc length is integral from 0 to 5 of square root of 25 over 25 minus x squared dx. Divide top and bottom by 25, like that. 0 to 5. This is 25 over 25 is 1. Square root of 1 is 1. 1 minus x squared over 25 is x over 5 squared. Okay, so do a u substitution. U equals 1/5 x. X over 5 is the same as 1/5 x. Du is 1/5 dx. So we need 1/5 here and a 5 here. See, 0 to 5 is for x. So x equals 0. If x is 0, u is 0. And x is 5. If x is 5, u is 1/5 of 5, which is 1. So my integral has a 5 in front. Integral from 0 to 1. 1 over radical 1 minus u squared du. That's perfect. That's my arc sine. 5 inverse sine of x from 0 to 1. Inverse sine of 1 is pi over 2. Inverse sine of 0 is 0. 5 pi over 2. And we see the answers do indeed match as they're supposed to. Over here. Okay, and I don't even know what number that was. Test 3, number 2. I don't even know where I am. Exam 3 question. Oh, that was test 3 question 1. Okay, I think I'm caught up now. Exam 4 question 1. Sketch the curve by using the parametric equations, blah, 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 blah. Okay. Test 4 number 1. X equals 3 sine t. Y equals t squared. Between negative pi and pi. Okay, so I made just a little table. T, X, Y. Negative pi and pi, so negative pi. How about negative pi over 2? 0, pi over 2, pi. Okay, sine of negative pi and 0 and pi are all 0. Sine of negative 90 degrees is negative 1. Negative 1 times 3 is negative 3. And sine of pi over 2 is 1, so that's 3. T squared, 0. Well, pi is like 3.14. If you square it, it's almost 10, 9.9. 9.9. And this is going to be 2.5, about 1/4. 2.5. Okay. So none of the y values is negative, so I'll just go like this. X goes from negative 3 to 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 9.9 is practically 10. Negative 3, 2.5, 0, 0. So it's going like this. And then 3, 2.5 back over here, and then back where it started from. Like that. Exam 3, question 7. Okay. I think in the interest of time, I'm not willing to work it all out. I'll just show you what it comes out to be. Okay. So you might have to look at the recording for this, because I don't feel like writing all 49 numbers. So I'll just show you what happened. So y prime equals x minus y. It came out very nice. You want to see the pattern. Maybe the easiest way to think of it is, if you have to think of it quickly, okay, let's look at this one. X minus y. Negative 3 minus 3 is negative 6, right? How about 3 negative 3? 3 minus negative 3 is 6. 3 minus 3 is 0. Negative 3 minus negative 3 is 0. And then just count by ones. I mean, just go by pattern. If you're going from negative 6 to 0, let's do this effectively. There it is. From negative 6 to 0, negative 5, negative 4, right? And then 0, 6. 1, 2, 3, 4, 5, 6, right? And just fill it all out. And there you go. Okay. So if you do all of the marks, here's a straight line right here. You can tell the arrows are going this direction. Then I pick a point below, curves like that. Pick a point above, goes like that. Okay. So that's what I want for that one. Okay, so yeah, sorry, I'm not willing to go slowly, but I did 4 of them. I did these 4 corner ones, and you can see how they're all off by 1. And you take the slopes, it goes something like that. Okay. Okay, let's see. Exam 3, question 1. Okay, I did that. Question 7, I did that. I think I'm caught up, but it's possible that I missed something. Okay, so here's the graph again. Go back up and check. Okay. All right, folks, it's a little bit after 8:30. I think I'm caught up, but I might have made a mistake. I don't have the full screen in the chat as it is, so I might have missed something. Okay, so if I missed something, put it again, or you can unmute yourselves. Find upper and lower functions for x and y, section 6.1. Well, thinking about something like this, I suppose. Okay.
Like for question 2, I was just kind of confused on how you found the upper and lower functions. So I was just wondering if you could cover that.
Okay. Unfortunately, I can't do computer running here, or maybe you can put it in chat. Yeah, 3 questions per test. Doing something about upper minus lower. I could do number 1 here. You want me to do number 1 here?
Sure, that'd be great. Thank you.
Okay. So test 1, number 1. X equals y cubed. Y equals x cubed. That means y equals cube root of x. The graphs are like this. Touch at 1, 1. Y equals x cubed. Y equals cube root of x. So it only asks for the area. So this is the upper, this is the lower. The area is integral from 0 to 1 of x to the 1/3 minus x cubed. Yeah, like so. So that's x to the 4/3 divided by 4/3 times 3/4 minus x to the 4th over 4. Plug in 1. 1 raised to anything is 1, so it's 3/4 minus 1/4 minus 0 minus 0. So that's 2/4 or 1/2. Okay, exam 5, question 2. We just most recently did, I think. That's 5, number 2. 0.636363. Write it as a reduced fraction. It's 0.63 plus 0.0063 plus, that's good enough. So the first term is 0.63. The common ratio is 0.01. So A over 1 minus R is 0.63 over 1 minus 0.01, which is 0.63 over 0.99, which is 63 over 99. Divide out of 9, 7 over 11. Okay. There's 3 questions per test, 15 total. That's what I have there. Okay, I think I'm caught up again. Just study the exams, yes. Questions will be just like the previous questions on the exams. They don't have to be the very same questions, although that's allowed, but I might just tweak it a little bit. So, okay, and I think I'm caught up with the chat again. Okay, so if I'm missing something, please put it in the chat again or unmute yourselves. Otherwise, we're done, folks. Again, reminder, give you a chance to think of another question or whatever. So Thursday, no questions, no questions and answers. We'll go straight to the final exam. We'll give you the entire time. It's not a different schedule. It's our regular scheduled time. So what, 7:10 to 9:25. So a little bit before 7:10, maybe 7:09, 7:08. I'll put the exam on Canvas announcements. Then when you join the class, just go ahead and get started. I'll also project it, over here for those of you who like that better. And then Class is over at 9:25 as usual, so I'll give you 5 minutes. You turn in the exam by 9:30, and then we're done. And of course, there's no homework to turn in this time. Okay. I think you're asking for exam 5, question 9 and 10. Is that correct? It's hard for me to read what you have there. Okay. Exam 5, number 9. Sine square root of x, 1 minus cosine 2x over 2. Okay, so you start with cosine x, which is x to the 0 over 0 factorial minus x squared over 2 factorial plus x to the 4th over 4 factorial minus x to the 6 over 6 factorial. And since I know I'm going to lose the 1 in front, I need one more term. Plus x to the 8 over 8 factorial. Okay, I reach the bottom of the paper, but cosine 2x, put 2x here, 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 here next. What it's going to look like. Cosine 2x is, okay, I'm going to change that to 1 now. 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial plus 2x to the 8th over 8 factorial plus dot, dot, dot. 1 minus cosine 2x is 1 minus all of that, which I wish I could just copy and paste, but 1 minus 2x squared over 2 factorial plus 2x to the 4th over 4 factorial minus 2x to the 6th over 6 factorial plus 2x to the 8th over 8 factorial plus dot, dot, dot. So these drop out and all the others will change sign. Okay, so it'll become, so this is 4x squared over 2 plus 16x to the 4th over 24 minus 64x to the 6th over 6 factorial is 720 plus 256x to the 8th over 40,320. And then just divide by 2. So we have what we want, 1 minus cosine 2x over 2. Okay, that's 2x squared. Half of that is x squared. And then that's 2/3, right? Half of that is 1/3. Okay, this one, just arithmetic, I'll just peek at my answer. Minus 2 over 45, x to the 6th. So I reduce this and then take half of it. Same thing, reduce this and take half of that. 1 over 315, x to the 8th, plus dot, dot, dot. And that fits my rule of having 4 terms in the answer. Okay, number 10, find T3, polynomial with degree 3 for f of x equals 10x. Okay, so f prime is secant squared x. F double prime is 2 secant x times secant x tangent x, which is 2 secant squared x tangent x. Side note, tangent of 0 is 0. Secant of 0 is 1. Plug in. F triple prime, first times the derivative of second, plus the second times the derivative of the first, and I'm going to be sneaky here, and you can be equally sneaky, I suppose. I'm not even going to find a derivative of this, because I know I'm going to plug in 0, and that's going to become 0. Okay, and if you want to do that same trick, you can do that. Okay, so we're plugging in 0. Tangent of 0 is 0. Secant of 0 is 1. Secant squared is 1. Double prime is 0 because tangent of 0 is 0. If triple prime is 0, that's gone. 0, 0, that's 2. So T3. Now, some of you put 4 terms. You weren't supposed to put 4 terms. You just want the 3rd degree Taylor polynomial and stop. So you stop when you have a cubic third degree. So it's x to the 0 over 0 factorial plus x to the 1 over 1 factorial plus x squared over 2 factorial plus x cubed over 3 factorial. Stop. Don't go any farther. So that's the e and the f exponent factorial. And now in front of them, I put 0, 1, 0, 2, 0, 1, 0, 2, which means that's gone, that's 1. That's 2 divided by 6, which is 1/3. So final answer is x plus 1/3 x cubed. There we go. Okay, my tests are all out of order now. I think I've caught up again. All right, so what time is it? Almost 8:45, 8:40. Okay, anybody else? Otherwise, we're done. If I didn't get your question in the chat, please type it again. And it's hard for me to, it's almost like I need a TA to keep track of everything I did here. Rather than scrolling back and down. Okay, so if I missed your question, please type it again or unmute yourselves. Otherwise, we're finished. Gen 5, question 1. Okay. All right, so it's alternating, starting with a negative. So that means it's -1 to the n. Okay, 1, 3, 5, 7, 9. That's 2 times 1 minus 1, 2 times 2 minus 1, 2 times 3 minus 1, 2 times 4 minus 1, and so on. So -1 to the n over 2n minus 1. Okay, is there going to be a polar graph equation? You have to be ready for that. Yes. Everybody bring a polar graph paper. If you're asking me, will there be one? I'm not promising that. You know, that's giving away the test. But you have to be ready for it. So bring a polar graph just in case I ask you for a polar graph, but it does not mean I have to ask you that, of course. Right? Exam 5, number 2. I think I already did that. Exam 5, number 8. Okay. 5, number 8. You go from 0 to 0.1 of 1 over 1 plus x to the 7. Okay, and to 6 decimal places, that's 10 to the minus 6. So 1 over 1 minus a negative x to the 7. So this is A, this is R. 0 to 0.1. So first term is 1, then you keep multiplying by negative x to the 7. Check this here. Okay, anyway, minus x to the 7th plus x to the 14th minus x to the 21st plus dot 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 dx, which is x minus x to the 8 over 8 plus x to the 15th over 15 minus x to the 22 over 22 from 0 to 0.1. Plug in 0, they're all 0. So 0.1 minus 0.1 to the 8 over 8 minus 0.1 to the 15th over 15 minus 0.1 to the 22nd over 22nd. Okay, and it turns out the first term is already less than 10 to the minus 6. Showing the first term to 6 decimal places. 1, 0, 0, 0, 0, 0. Okay. Some of you had 0.1. It says 6 decimal places. So it should look like this. 1, 0, 0, 0, 0, 0. And maybe not from a mathematical standpoint, but from a scientific notation standpoint, this is considered more accurate than this, right? If you're in a science lab and you give an answer like this, you're being very, very accurate, right? That's accurate to 10 to the minus 6. If it's like this, you're just accurate to 10 to the minus 1, which is obviously not much. Okay. All right, I think I've caught up again. So reorganize my papers again. All right. Anybody else? Any more, please? If you say I didn't get to your question, put it back in the chat. Okay, it's hard for me to, like I said, scroll down and get everything and give you the answer at the same time. Okay, so anybody else, please? Either unmute yourselves or put it in the chat. Otherwise, we're finished. Wait a little longer. Okay, then I think we're done, folks. All right, so that's about it. All we have left is one last class this Thursday for the final exam, and then we're done with the course. All right. Okay, so have a good night, everybody. Study as well as you can for the final, and we'll see you all on Thursday. Okay. All right. Good night, everybody. Bye.
Wonderful.